am one of the instructors here at Sinclair College. Today we're going to talk about AC diagnosis, specifically AC pressure diagnosis. And so a lot of times when we have AC concerns, they're related to maybe lack of refrigerant due to a leak. But what about a vehicle that comes in that has weird pressures, and pressures I mean that are not normal? Typically on a typical 80 to 100 degree day with decent humidity, you're going to look at low side pressures that maybe hover around 20 psi, 25 psi, and may change. High side pressure may be 200 to 250 psi, varying, of course, with airflow and humidity and ambient temperature. However, let's say a car comes in and it actually has higher than normal low side pressure, so instead of being that 20 to 30 psi range, it's around 50 to 60. Now, there's going to be some gray area. This doesn't mean that the pressure is going to fall exactly in this range. What if your high side pressure is lower than normal? So if it's typically going to be 200 to 250 and you see that that's lower than normal, maybe what you're experiencing is this concern right here. So let's go through the refrigeration cycle. Let's talk about this real quick and let's talk about what happens. At the inlet of our compressor, we're going to actually have what they call low pressure vapor coming into it. So on either side of our compressor, we're going to have vapor. Coming out of our compressor, its main job is to increase pressure. The compressor is nothing more than a pump, just like an engine. And so it's going to take 30 psi and maybe equate that to 200 to 250 psi on the high side. So coming out of the compressor is considered to be our high side lines. And it's going to be what we consider to be high pressure vapor. From there, in our refrigeration cycle, it goes to our condenser. Our condenser's job is to take high pressure vapor and condense it back to a liquid. So if we look at this, vapor is going to enter the condenser and it's going to leave as a liquid. So we got droplets basically coming through there. So we have a change of state here, but not a change actually in pressure. It may drop slightly, but not a lot. So coming out of here, we're going to have high pressure liquid. And that's super important because the next thing that it's going to be going to is our metering device. And our metering devices are thermal expansion valves or our orifice tube on some of our older vehicles. And the process of that is it's going to take high pressure liquid and it's actually going to change it into what we consider to be low pressure liquid. And then where the magic actually happens in our AC system is going to be where we take air that's coming in from your vehicle, 90 degree outside air, and that air is going to be passed through our air plenum. It's going to go to the evaporator. We're going to have heat transfer, and it's actually going to cause refrigerant to vaporize. And so coming out of this, it becomes a low pressure vapor. So again, we change state in the evaporator from low pressure liquid to low pressure vapor, and this is a complete loop cycle going in the counterclockwise direction. However, one thing that is not found common in service information is the discussion about a compressor that may have failed. And I'm not talking about leaks, I'm talking about a compressor that won't pump anymore. And the term that we're going to give that is compressor lacks capacity. This is why we're doing this video, is because you don't find this very often when you're actually working on vehicles in service information. So if you're looking at pressure diagnosis, they'll talk about failed metering devices, they might talk about obstructive condensers internally, and they're going to talk about a lot of different things. But what they don't talk about is if a compressor won't pump anymore. And so it's called a weak compressor. So what we're going to show you to do today is actually how to go in there and diagnose this on a car and how to force that compressor to increase in pressure to overcome ambient temperature. And I have to give a shout out to my past automotive instructor, Keith Reinhardt. Mr. Reinhardt taught me air conditioning, and this was one of the things I valued from this class because I could never find it in a service information or service manual anywhere else. So this is going to be something that he taught me, and so that's why it's really important to go and get automotive education or automotive training in the aftermarket, is so that you continue your skill set to grow that. So we're going to show you on a vehicle in order to how to get a pressure to pump. So we're going to go to the vehicle now. All right, so what we're going to do is we're going to hook up our AC machine, and we're actually going to go ahead and watch our low pressure and high pressure gauges. The AC system on this vehicle should be functioning correctly. This is a vehicle that has about 200,000 miles. It's a 2006 Honda Accord with a 4-cylinder. So no customer complaint right now, no concerns on it. So we're going to go ahead and actually connect our low side and high side gauges, and we're going to do that. And we'll bring the camera around and show you the connection of those right here. And so our smaller port is going to be And you can hear a little bit of a hiss there. It's probably some residual refrigerant. And we're going to go ahead and connect our low side gauge. Smaller port. This is an R134A system. We're going to connect our high side service port. Make sure to get that coupler on there. There we go. Run it down to access the refrigerant pressure. So now we'll be able to see this on our mechanical gauges on our machine. So if we come back over here to our gauges, they should show approximately 70 to 75 psi. And you can see these pressures are what we call static pressures. And this is between 50 and 70, 50 to 100, which is about 75 psi, approximately 75, 76 psi here as well. And so that aligns with ambient temperature. So the next thing we're going to do is start this up, and I'm going to show you how to get this compressor to pump. So I'm going to start the vehicle, turn the AC button on, and we're going to watch the gauges. All right, so we turned on our machine and our vehicle is running, our AC is running. You can watch that whenever our compressor kicks on, we're going to get it's going to come down to about maybe 20 to 15 psi, somewhere in that range. So you can see that the low side goes down to 20 psi. It's going to cycle off once it hits evaporator freeze up. And you're going to watch our high side gauge is going to start to be about 125 to 140. The system, the pressure start to equalize here. That's how we cycle the system to prevent evaporator freeze up. Now, if for some reason this gauge was higher than normal and this gauge continues to stay closer to 100, 125, the reason the high side pressure is not very high is the vehicle's not up to operating temperature. And inside the shop here, it's only about 75 degrees with low humidity. So if it was hotter outside, 90 degrees, and a lot of humidity, this high side gauge would be higher. So now what we're gonna do, we're gonna turn the vehicle off, and I'm gonna show you a trick here, and we're gonna pay attention to our high side gauge. Notice right now it's around 125 psi. So if we thought this compressor was not working and not doing its job, we're gonna show you what to do next. So I'm gonna turn the vehicle off, and we're going to show you what to do on the vehicle. So what we're going to do is we're actually going to disconnect what they call the electric cooling fans. Now one of these is most likely a radiator fan, and one of these is what they call the condenser fan. Even though on this vehicle the condenser is stacked in front of the radiator, they are actually kind of considered to be separate fans. So one's going to be on with AC, one's going to be on with cooling temperature. By disconnecting the fans, that transitions or keeps the airflow from basically transferring into the condenser. What should happen is, if our compressor is doing its job, is it's going to have our high side pressures go from maybe 125 to 175. And the reason that's being is it's working harder to overcome the ambient temperature. So I'm going to come down here, I'm going to use my screwdriver to depress my lock tab, and we're going to try to get this to unplug here. So give me a second here to get that unplugged. So that one's disconnected. We're going to come over to this one. We're going to depress the locking tang. See if we can get that to work free. And that should come out. We're going to start the vehicle up. When doing this, you need to pay close attention to not let the vehicle overheat. We're mainly looking at high side pressure to see if the high side pressure goes up. So what you're going to see is we've actually started this vehicle and the high side gauge started to run. I'm going to restart the vehicle with AC on. You need to pay close attention because if this high side gauge gets up into 300, 350 range, we want to turn it off. So we're going to start the vehicle, watch the high side gauge. It should instantly start to climb because our cooling fans are disconnected. And hopefully, if our compressor is working correctly, our high side gauge would rise. So pay attention to that high side gauge. Start the vehicle, AC system on. You're going to hear the AC clutch kick on. High side pressure starts to climb instantly. And this is a good thing. Now, we don't want this getting too high, so if it gets to the 350, we're going to turn off the AC machine. Turn off the AC system, excuse me. And you can see it continues to increase. So I'm going to turn it off. And you can see that our high side pressure got up to about 300 psi. So let's go back over to the board and explain why this is. All right, so let's recap. If we had a vehicle that had higher than normal low side pressure, so instead of being down in that 15 to 20 psi range, it ranges maybe between 40, 50, or 60 psi when the AC compressor is engaged, Our high side never really builds, it doesn't get up very high. Then what we're looking at is a possible issue with the compressor. So on the vehicle that we had, it had twin electric fans. We disconnected both electric fans. That means no airflow is coming across our condenser. That means that the compressor has to work harder to get the high side pressure higher to get a difference in the temperature of the refrigerant compared to outside temperature. And so when we disconnected that, what happened is our high side gauge climbed all the way to approximately 300 psi. And what that tells me is that when the high side pressure went up, the compressor is good. So on this vehicle, there's nothing wrong with the compressor. Now, on a vehicle that has an issue with the compressor lacking capacity, what would happen is when we block the airflow, so we disconnected the electric fans, we take a fender cover potentially and block the airflow from the grill opening. If it's a manual or mechanical fan, we would actually physically take it off and not allow any airflow. And the compressor was bad, this high side gauge would not increase very much. As you can see, when you disconnect the cooling fan or the condenser fan, instantly within 15 to 20 seconds, our high side went up almost to 300 psi. We turned it off to make sure that we didn't have any issues with our refrigerant pressure escaping from the vehicle to the relief valve. And so this is a way to diagnose a compressor that lacks capacity. Again, so we're looking at high side pressure. We disconnect or block airflow across the condenser to condemn what a compressor that won't pump. So hopefully you like this video. For those of you that do any AC work out there, you can go ahead and check this one out, and hopefully this will be helpful for you in the future. Thanks for tuning in, and follow for more videos.